All right, let's look at the Taylor series. Right. So Taylor series goes something like this. F of x is equal to summation, n goes from 0 to infinity, then nth derivative of f evaluated at a over n factorial, then quantity x minus a to the nth power. Right. So this Taylor series centered at x equals a. Right, and the Maclaurin series is simply a special case of a Taylor series where a equals 0. So you just put the 0 for a, you get that formula. All right, so let's try to derive this Taylor series formula. All right, so we're going to start with f of x. Right, say we have a power series for this guy. So since we don't know the coefficient, so I'm going to just write it a general power series. So n goes from 0 to infinity. Right, we don't know the coefficient, so I'm going to call it, say, Cn. So we're trying to find Cn. Then you have quantity x minus a to the n. All right, so everything kind of boils down to finding that Cn, right, coefficient. All right, and I'm going to just write it out so that we can kind of take the derivative a little bit more easily. So you have a C0 plus C1 times x minus a plus C2 quantity x minus a squared plus C3 x minus a cubed, maybe just one more, C4 and quantity x minus a to the fourth power. Right, and so on. So this keeps on going. All right, so let's try to find a C0. C0 is easy to find. All you have to do is plug in x equals a into that expression. All right, because second term on, it has a x minus a. So if you plug in x equals a, you get all zeros. All right, so you get just a C0. All right. C0 is identical with f of a. All right, so let's take first derivative. F prime of x is going to be, all right, so derivative of C0 is 0 because it's a constant. Derivative of C1 at x minus a would be just a C1. And then derivative of that is put 2 in front, just using a power rule. C2 is just a number, and then you have a x minus a to the first power. Subtract 1 from the power. The next term derivative is going to be 3 times C3 and quantity x minus a squared. All right, then the next one is you're going to put the 4 in front, and the C4 x minus a, raise it to the third power, and so on. All right, then we can do the same trick to find C1. C1 is simply plug in a into the first derivative function. Right, so you're gonna get C1 here. All right, and we take another derivative. Maybe we take a couple more to see if we can get some pattern here. So take the derivative here, f double prime of x. All right, then C1, derivative of C1 is 0 since it's a constant, and derivative of that would be 2 times C2. And the next one is 3 times 2, put 2 in front. You have a C3. Then you have a x minus a. All right, plus 4 times 3 times C4 quantity x minus a squared, and then and so on. All right. All right, then we can plug in a again. Then we can find the 2 times C2. Right, so let's take another derivative, f triple prime of x, right? Derivative of that is 0, and derivative of that is 3 times 2 times c3, and plus, right, you're going to get 4 times 3 times 2 times c4 x minus a to the first power, and so on, right? So if you plug in a just like before, so f triple prime of a, you're going to get 3 times 2 times c3, right? Then let's try to detect a pattern here. So instead of writing 3 times 2, you can think of it as 3 times 2 times 1. So that's actually 3 factorial times c3, right? And 2 is really the same thing as 2 factorial c2. So this is, I'm going to write it as a 2 factorial c2. And 1 factorial is 1, so it's 1 factorial c1. And this is going to be 0 factorial is defined to be 1 c0. Alright, so you can see the pattern here. So therefore, following the pattern, if you take the nth derivative of f, then evaluate it at a is going to be, right, third derivative 3 factorial c3. Nth derivative, obviously, it's going to be n factorial times c sub n, right? Remember that we're looking for cn, so I'm going to divide this guy through by n factorial, so that we have cn is equal to nth derivative, and evaluate it at a, divided by n factorial, right? That's where this coefficient of the Taylor series comes from, all right? All right, that's pretty simple, right? And a Maclaurin series, the same thing with just a is equal to 0. All right, that's it. I hope that this was clear.